Sometimes when we're multiplying binomials, there's things that are special products. So if you look at this first example, we're actually squaring a binomial. So if we're squaring a binomial, we can obviously do what we would normally do with anything and think of this in expanded terms. So if I wanted to expand this out, I could write 3x plus 1 times 3x plus 1, which is just like squaring a binomial. It's obviously squared, and now I'm going to use my concept of FOIL, where I'm doing first, outer, inner, last. So the first times the first being 3x times 3x, outer times the outer, inner times the inner, and last times the last. So 3x times 3x is going to give me 9x squared. 3 times 1 is going to give me 3x. And then 1 times 3 is going to give me 3x. And 1 times 1 is going to give me 1. This is going to simplify to 9x squared plus 6x plus 1. Pretty easy to do. Okay, if we look at this next one, we're going to have the same thing. We'd have something that is going to give us a minus 3 times a minus 3. First, outer, inner, last, we're going to get a squared minus 3a minus 3a plus 9. And that's going to be a squared minus 6a plus 9. Now, if we look at this, there's a few things that we can kind of notice about this. So first, this is just this squared. And this is this squared. Well, that's easy to see. So now I know my first term is going to be the first value squared, and my second term is going to be the last value squared. And if we look at the second example, we've got the exact same thing. A squared is right there. Whoops. Negative 3 squared, and the sign is important, is right there. But what about this middle term? In both cases, the first case we've got 6x, the second case we've got negative 6a. Well, if I look at those two terms, 3x plus 1 and 3x, so what I've done is I've taken this and kind of looked at it. Well, that's the same as 2 times 3x. Well, 2 times 3x, it's kind of hard to see with this one, but 2 times 3x is really what we've done is 2 times our value right there. We've done 3x times 1 and 1 times 3x if we look at our FOIL. But if we just multiply that together and then double it, that's the value we're getting. If you look at the second bracket, we've got negative 3a minus 3a. That's how we got our negative 6a. Well, that's equal to 2 times a times negative 3. A times negative 3 is negative 3a. Negative 3 times a is negative 3a. So we've got two of them, and we're just multiplying it together. So in general, what we can kind of consider then is that if we want to do a binomial squared, it's going to create a perfect square trinomial, which is always going to be our first value squared at the start, our last value squared at the end, and then we take whatever sign is in the middle and we write plus 2 times our first times our last. So if we look at the next one, we're going to have the first value squared plus the last value squared. And in this case, negative b times negative b would still give me positive b squared. Now, the only thing that's going to be different is here we're going to have minus 2ab. So when we're looking at squaring a binomial, square the first, square the last, multiply the values together, and double it. That will always give you the right answer. If you want to work through and FOIL your question, you're just adding in an extra step, which sometimes it will create a little bit of a time crunch when you're working through problems, but you will still always get it right. If we're looking at something like this, now this looks like we're squaring a binomial, but what's actually a little bit different is we've got a positive and we've got a negative. So it's slightly different. So putting these values together, what we're going to look at is we're just going to FOIL our values just to see what the answer is going to be. So 2x times 2x, 2x times negative 5, positive 5 times 2x, and positive 5 times negative 5. So we're going to get 4x squared, first times the first, minus 10x, outer times the outer, plus 10x, inner times the inner, and then minus 25. Well, plus 10x and minus 10x, that's going to cancel out. So that middle part is going to go away. So we get then 4x squared minus 25. So when we're looking at this, because of that positive and negative, we've actually got rid of our middle term. So considering this, we're multiplying identical binomials, but the signs are different. That's very important. Okay, so you're multiplying the identical binomial with different signs. So this has to be the exact same when we're doing this. Now the confusing part is, if this a and b are actually switched, we still have an identical binomial because a positive and a positive doesn't change anything. So sometimes you might see that written like that in a textbook or perhaps a challenge question. However, when I look at this, if I have identical binomials with different signs, all I'm going to have is a squared minus b squared, because the middle signs are going to erase each other. They're going to go away, just like this. Those middle values where we had negative 10x and positive 10x, they just cancel each other out. So if we look at kind of a final example here, and we're going to put all of our concepts together, what we're going to do, if I looked at this to simplify it, I'm going to leave the 2 because I'm going to FOIL everything, or I'm going to multiply binomials together first, and I'm going to get something like this. So 2. Now I'm going to square this binomial. Square the first, we get 9x squared. 3 times 3 is 9. I'm going to square the last, plus 16. And then in the middle, I'm going to have that middle sign. Then 3x times 4 is 12x, and I'm going to double it. Multiply them together and double it. So we get plus 24x. Close my bracket. Minus, I'm going to put a bracket here. I've got identical binomials. The only thing that's different is the sign. So then I know I can square the first, 16x squared. 4 times 4 is 16, x times x is x squared. And then minus square the last, 25. Now all I have to do is multiply that 2 in. So we're going to get 18x squared plus 48x plus 32. And now I have to change the signs here. Minus 16x squared plus 25. And now I need to collect like terms. 18x squared minus 16x squared is going to give me 2x squared. There's only one x term, so plus 48x. And then 32 plus 25 is going to be plus 57.